get our amazing speaker, Vanessa Callahan, the nerdy naturalist, up on stage and sharing your brain.
Hello. Can everyone hear me on my multi-mic system? Excellent. Please hold while we do a very graceful technology transfer that is sure to go flawlessly. Hurrah! Here we are. Cycles. We're talking about cycles today. Subtitle, How to Survive in This Crazy Wild World. I am Vanessa. You can call me Vanessa the Nerdy Naturalist. My official job title here at Denver Botanic Gardens is Assistant Manager of Learning Engagement. Part of our learning engagement framework is to engage with people and not lecture at them from afar and create PowerPoints. So, well, first of all, big thank you to Hannah for actually creating this PowerPoint because I am an adult for sure. And secondly, I'll be doing lots of question asking. They're not rhetorical, please engage with me. This is not the kind of presenting of information I typically do. Welcome to Denver Botanic Gardens. Anyone here for the very first time? Oh, a handful. Awesome. Well, please make sure you visit the art galleries when we get out and go outside into the gardens. And our conservatory just reopened last week. Hooray! So you can go into the lush tropical rainforest and it's very nice for your skin. I suggest 15 minutes in there daily. So all across, wait, how come I'm not seeing my notes? I need my notes. All across the world, what did we say? 69 countries. Creative Mornings today are talking about cycles. But not all of them are talking about, oh boy. Flawlessly.
Do you need your notes?
Yeah, well, all right, I can survive. Don't worry, I have them written down. Oh, there they are. We're here.
We're not here. There, we're here.
There, we're here.
Should we adjust lighting too?
No, I like light. I like to see people. Yes, 69 countries across the world, people are talking about cycles at their Creative Mornings, but not all of them are talking about the law of conservation of mass. That is just for a lucky select few. You self-selected to be here. Congratulations. Raise your hands if you remember the law of conservation of mass. Oh, that's good. Yeah, okay. This has to do more with chemistry and physics equations, but we're gonna use it as kind of a little mantra to help us. So mass, in this case, is neither created nor destroyed, but it can change form, right? It can change shape. And this, again, to make all the numbers right, you gotta get kind of down to a molecular, granular level, but just conceptually big picture, this is true all the time, right? All of life, being alive, is cycles. When we create life, we don't build it out of nothingness. We have those building blocks, we just rearrange them. And when life is lost, it doesn't just vanish into thin air. It's not destroyed, it goes to other places. So we're gonna talk about how that happens a little bit today, primarily through the eye of plants. So a little background. Cool, Hannah, I'm gonna tell your computer to update at a later time. Is that good? Quick refresher on plants. There are a few things plants need to stay alive. Some of these will be familiar. Water, good. Sunlight is very important for plants. Also, just air in general. All of us need air. Even things that live in the water are getting their air somehow, typically oxygen, other things too. And then nutrients, sadly, we're not really going to talk about today. That's soil, a lot of soil stuff. That's a whole nother ballgame. We don't have time. But if you have the right amounts and the right levels of these things, plants can survive. Real quickly, let's just Okay, we're here in Colorado. Here we are. In case you're unaware of Colorado climates, we have not so much water. The mountains do have some, but we'll talk about some of that later. We get a lot of sun. We're high up, so we also get a lot of that solar radiation. And then especially down here in the lower elevations, we have hot summers, cold winters, and again, our soil is we'll say special. Special soil. It requires special adaptations, but we're not going to get into soil today. Okay. Cheating on our cycles overview a few slides previous. Thank you for not reading the water cycle, because this is our first quiz. Does anyone go back to second grade? Who remembers the water cycle? We're going to start in the sky. All the water droplets form into a cloud. What's that called? Condensation. And then once the cloud gets so heavy it can't hold all that water anymore, it comes down as rain or snow or sleet. Precipitation. Oh, you guys are doing so good. I learned from some second graders a while ago. When I was in second grade, there was just like 3 things. But now there's runoff, so that's like how the water gets to like the rivers and stuff, and then eventually gets down to the ocean. But the second graders these days call this aggregation. I know, they got words for everything. Then the water in the big bodies goes back up into the sky. What's this called? Evaporation. But in the meantime, all of us living things also need water, right? Life as we know it is based on water. So all of our plants are going to be drinking water. And then also all of our plants are going to be letting water evaporate out of them. Well, they're not letting it, but that's what happens. Does anyone know what this is called? The water leaving plants and going back up into the sky? Oh my God, are you guys secretly botanists? I'm about to look real silly. This is transpiration, AKA plant sweat. Yeah, get ready. Okay, so plants have these very small pores on the underside of their leaves. Look at this great poster.
Where'd you go?
One of our researchers, had this made, and I use it all the time. These are stomates. They're tiny little pores on the underside of a leaf, and they can open and close. So like, here's a closed one, here's an openish one. And they let stuff in and out. Air goes in and out here, so this is how they breathe, but it's also where they're gonna lose water out of. Okay, so Hannah, say we have, you wanna come up here for me? Mm-hmm. Pretend that Hannah is like a 5'5" tall plant. Here she's got some leaves. Where does Hannah drink water from? Her roots, they're underground. Yeah, so how does the water get from the ground to like Hannah's head and arms? How does it move? Yes, there are veins, so those are the tubes we're going to travel through. We have a heart, right? We have a muscle that pumps that stuff all the way through our body. Plants don't have muscles. They pull that water up through transpiration. The losing it out of their pores, the pulling of it into the air, pulls it up from the ground through their tubes and throughout the whole body. So that water carries, the minerals and nutrients that we're not talking about today to all the parts of the body. So very important system if you don't have a heart to pump you, but also a thing we need to consider in the summertime. Mm-hmm. Thank you.
Was I not? Right.
Oh yeah, should we do this? So,
yeah.
As a quick visual demonstration of how that water moves, right?
Wait, look at what I set up.
Look at what she set up. Another flawless transition, don't you worry. So water has all these special properties that allows it to like climb, basically. Oh, we can do it at an angle. Ooh.
Wait, but we're not up here yet. Why? HDMI out.
HDMI out. Oh, something's happening. Nothing's there. So if you're not made entirely of Bounty cotton fibers, you're gonna need a little help with that pull, right? Also, the timing could be a problem. So this is how water's going to get pulled through your plant's body. But again, to actually like start the motion, we're gonna need those pores to be sweating water out the top.
Okay.
Thank you so much. Oh yeah, now we gotta go back to this. This was a flawless plan. Ta-da. Okay. So plants sweat, that's what happens, that's... Plants sweat, that's great, keeps them alive, but also let's think about in the summertime here in Colorado especially, right, and in other hot, dry, or semi-arid places. If we are, okay, we're out in the desert, we're imagining it because there's no picture. We're out in somewhere hot, there she is. We're out in the heat in the summertime, hot and dry, we're gonna bring a lot of water with us, right?
Yes.
We need to hydrate constantly. Also, you're at altitude, make sure you hydrate, right? This girl needs a hat. I don't know what she thinks she's doing. This is gonna be a big problem for her. So now let's imagine we're a plant. Anyone here a gardener? Anyone here do a little gardening? Okay, great. We have veggies in the garden particularly. Like how often are you watering your veggies in the summer?
If not twice a day.
Oh my God, look, I'm an every other day because I'm a lazy person. I'm like, tough it out, learn to be strong. But yeah, we have to water our plants every day basically in this area. So what about plants that don't have a dutiful servant to tend to them twice a day? Morning and night. Oh, that's, I still would forget. So those plants need to make some sort of plan, right? They cannot survive with just depending on someone to come and water them. So thinking back to the beginning when we talked about what our plants need in the daytime, in the summertime, sunlight. Yeah, we got that? Oh, I fixed you. Okay. Water? No. We don't really have a lot of water. And how about air? We have air. Air we can regulate, right? So these stomates can open and close to let air in and out, and that's also going to let or not let water out. So what some plants, notably our cacti and other succulents, like very deserty plants are gonna do, they're just gonna close up shop during the day. They're gonna lose a lot of water. Like it's really hot and it's really dry. So they're gonna be in a net negative, losing water if those pores are open, right? So that water cycles up from the ground, out from the top, but if it's too hot and dry, they're gonna lose too much is going out and there's nothing to replenish from the bottom. So we're gonna close up shop. Pores all closed during the daytime, that's fine, no water loss, excellent. But it also means we're holding our breath all day. We're not breathing, which plants can do. Like that'd be very bad for us, right? Not an option, but plants can do that. But if we go back up to sunlight, why do plants need sunlight? What are they using that sunlight for? For photosynthesis, to make all of the food that fuels all life on Earth. So mildly important. And for photosynthesis, those cycles, those like 4 different cycles, we're definitely not gonna get into because I don't remember how they work. But we need that gas exchange. We need to be breathing to make photosynthesis happen. We used carbon dioxide, we break apart the carbons, we put them into sugar chains. That's as far as we're gonna get. But we need that gas exchange to be able to build the food, like literally the building blocks of the food. So that makes it hard if during the sunlight times we're not breathing, we're not doing the gas exchange. So don't worry, they have a plan. They have a plan. They're going to, at nighttime, open those pores. You're gonna lose a lot less water at night. It's not nearly as hot. We're gonna do all the gas exchange. They're gonna break down and store all the things they need from the gases. And then in the daylight, close up shop, no breathing, no losing water. And then they can pull out from their storage, well-organized storage system, unlike mine, they're gonna pull out all the gas, all the components that they need to photosynthesize using the sun. Now we're definitely gonna make this work. Okay, so this is the thing I just described to you is one of 3 main methods of photosynthesis. They're gonna go, wah. One way that plants photosynthesize of 3 main methods, all of those methods, right, they're all just taking these primary components and building food, but all of them are going to be how they regulate these different internal cycles based on their environmental conditions in order to kind of most efficiently make the maximum amount of food without, dying because they held their breath too long or something, or didn't have enough water. Oop, we going again. Okay. This is to say plants are amazing and incredibly adaptable and can do anything and everything in the world, right? One of 3 ways to photosynthesize. The building is the same, but we have all these different mechanisms to regulate because plants are going to live everywhere. I got my clicker. We have plants in really dry areas, really wet areas, really high areas. We have really big plants. We have really little plants. We have soft plants. We have spiky plants. There's an incredible diversity of plants because they are all adapting to different needs in different ways. Even in the same environment, there's not one correct way to manage all of our cycles. There's a lot of correct ways. Yeah, I know. Okay, so now let's think about us now in the winter time. Let's see if these are gonna work. Great, we have the same sort of needs. Sunlight, how's our sunlight?
Short.
Very short, right? Sad times. This means a lot less food. Does anyone feel here like not love the darkness of the winter time? Yeah, there's literally less life-sustaining food being made that's in our area, at least. We bring it up from other areas. How about water? What's water availability like this time of year? Yeah, this one's a little bit tricky. We should be getting some amount of snow. Certainly in the mountains we have some snow, but a lot of that water is frozen, so that's not really drinkable. And even if there is water, the ground is really cold. We'll do a touch of physics again. When stuff's cold, it doesn't move very fast. That's slow movement. So it's just hard to utilize the water, even if it's available, generally because it's frozen or it's just very, very, very cold. And how about air? What's our air like? It's cold. It's cold, and for us, it's also dry. And again, that cold just makes it tricky. If things are frozen, if the inside of your body is frozen, that's very bad. If the inside of a plant's body is frozen, that's also very bad. Frozen things don't work well. They generally die. And even if it's not freezing level, that slowness of the air just makes it hard for all those chemical processes to occur. So that's a little trickier for plants in the winter, but don't worry, we have 1,000 different adaptations. What do plants do in the winter? Raise your hand if you think all the plants die in the winter. Oh, thank you. There's so much life in this photo. There's so many things that are alive. Let's look at these big old cottonwood trees over here. What happened to these trees? What did they do in the fall? They shed all their leaves. What do leaves do for plants? They're green, they photosynthesize. Yes, they also are transpirationing. The green makes food. Also, these are pretty delicate, so they're gonna die. We made food in the summer, right? We did all that work. Now we're pretty much in a hibernation mode, right? We let them go. We let them die, but they're gonna fall to the earth and feed other things and do other things. And we're gonna grow new leaves in the spring, but we're not trying to deal with this time. It's not worth it right now in this phase of our lives when there's really cold temperatures. There's not enough sunlight to even make enough food to make that worthwhile. So we just let it go. We let it go. Now's not the time. It's time to store all that food underneath. We're still very alive. We're still very functional. We just know when to take a break. We've also got all these little guys over here. Similar stories. It's just that they don't have big, giant woody trunks, so they look like little dead brown sticks. They are dead brown sticks that are above ground, but they've done all their work, sent their food down into their roots, very much alive underneath, worked hard, prepped hard. They know what they're doing. They're adults, and they're very responsible. You can also go out into the gardens. If you will notice, please ignore holiday lights in these photos, but these were taken very recently. You can go out and find lots of color in the gardens right now, today. Anyone know what these little red blobs are? These are crab apples. We have a bunch of crab apples lining Shady Lane. You can go see them all full of their little red apples right now. Do we see any leaves on this tree? Nope, just like the cottonwood, we dropped our leaves, so we're not actively making food and actively like growing and actively like doing live stuff, but we made these foods. Who's gonna enjoy these foods, these crab apples? Birds, squirrels, we have a couple animals that hang around like throughout the winter, and they're gonna be hungry still, so a lot of fruits are gone at this point, but if you're the only one left, you are also the best tasting one. So you're gonna be very popular with the few critters that are gonna be out. How about this plant? What's this plant? What kind of plant is it? It's a pine tree, right? So we call these, all these kinds of trees that stay green all winter, the evergreens, that we know them as conifers. For us, generally conifers are gonna be evergreen. And they're gonna keep those needles on all year. They are constantly cycling through them, but like how we go through hair, right, it's constantly falling out and constantly growing in, unlike those cottonwood trees where we lose them all at once, grow them all again very dramatically. These are just a regular cycle. So part of the reason this works, what do we notice is a big difference between these pine needles, these look like a spruce, but spruce needles, and this other leafy tree here? What's the difference between these two leaves? Shape, yeah, these are a lot flatter and wider. That's a lot more surface area, a lot more stomates, so they're gonna be able to make a lot more food in the spring and summer because they have a lot more photosynthesis and a lot more gas exchange. But these are going to be a lot more resistant to water loss and to freezing because they're all bundled up. And you see that white coating on them? They have a nice little jacket, a little waxy coating that keeps them dry and keeps them kind of sealed off. So they can withstand those harsher weather conditions in that season. And that means they don't have to start fresh every spring and grow a whole bunch of new leaves. Also, they get a head start. When it's, 75 degrees on March 2nd, there's no leaves on this tree. They're photosynthesizing. They're at work, constant. They're just like a medium level constant energy. We see some other things, not just conifers with those needles. Our Oregon grape is gonna have super waxy leaves again, and we still have berries. Go out in the garden and find all of these plants. And then my favorite strategy is the cactus flop. Oh, we got really high. Our cactus flop here. So we looked at cacti before. Cacti are succulents, so their bodies are full of water. And what happens? Has anyone ever put a beer in the freezer? What happens when water freezes? It expands and explodes and breaks things. So if your cells are all full of water and they freeze and expand and break things, that means your body is ripped apart by ice. So they're just gonna dehydrate a little bit, reduce some of that water, which is gonna make them flop. These are mature adults. They are very healthy. They're doing exactly what they need to do to survive. They're also not dropping all of their body to just start fresh. This is all gonna come back in the spring. This is living tissue. They are doing exactly what is needed for them to stay alive through the cold times. I'd like to play a little game with you real quick. I know we're low on time. We have 4 pictures, 4 different adaptations. Take a moment and think about which one you are. So top left, number 1 there. We have gone fully dormant. We've dropped all the leaves. We're not trying to be the most alive, but we've left baubles on. We're doing it for the kids. And we look festive. We have our evergreens. We're constant, we're steady. We're never gonna be doing the most, but we're also not just disappearing into the ether, right? We're just always there. We're always constant. We're always steady. We've got a cactus flop. We're also doing what we need to survive. That looks really different, winter and summer, but is absolutely the right move to stay alive. And then we have all of our kind of common deciduous-y things where we just let above ground go away. It's not the time, it's cold and it's dark. So we're just gonna burrow down underground for a while and we'll see you in the spring. Raise your hand if you're number 1. Looking showy, but you're actually asleep. Number 2 are steady conifers. Steady, even keel. Oh, you guys are well adjusted. Anyone going for the cactus flop? Yeah. And how about gone, see you in the spring? A couple. Cool. Would just like to say, this is the time where we're going to attempt to make some connections between people and plants. I think it is really hard for people because we are so to exist within a society, which are the constructs we have to exist in. There are right ways and there are wrong ways. But no, there's not. There's so many different ways you can do it. And yes, it is really cold and it is really dark. And those are real things. These cycles of the earth literally create life. They are responsible for these cycles inside us, keeping us alive. So those are real things that you really need to respond to. And there's a multitude of ways to do that. Don't prescribe to the one right way. It doesn't exist. Your cycles will be different from the person next to you, and your cycles will tell you, if you listen, what you need to be doing to get through this cycle, right? Thank you all so much for joining us. It is the mission of Denver Botanic Gardens to connect people with plants. I hope we all learned a little bit about stomates, if you want a new vocab word, a little bit about transpiration and how water moves through plants, and just about how we can all survive a little bit, take some inspiration from plants in this time. If you'd like to learn so many more super fun and edutaining facts about plants all the time, catch me on the gram and the Tickety Talk. If you do that, I'm usually there twice a month at Denver Botanic. We're something of trendsetters over on our social media team, if I do say so myself. So we have a lot of fun. We are trying to actively engage other gardens and other community partners as well. I think we're fabulous. We can.
Drawing to a close, we have some few closing remarks.
You want the stomate poster? Thank you so much.